What if I told you there is a plant that stores food underground for a decade? It survives droughts that turn wheat fields to dust. It feeds a family from a single garden plot. And for thousands of years, it has protected millions from famine in one of the harshest climates on Earth. But you have never heard of it, not because it failed, because it cannot be owned, it cannot be patented, it cannot be sold in annual cycles. And in a world where hunger is profitable, a crop that ends it for free is a threat. This is the story of the food we were never supposed to find. 9. The reveal. Enset, the false banana. The plant is called Enset, known across the scientific world as Ensete ventricosum. In the villages of southern Ethiopia, people call it the false banana. It towers like a banana tree, broad leaves fanning outward, trunk thick and green. But the resemblance ends there. Its fruit is inedible. The value lies hidden beneath the surface. Inside the trunk and buried in the underground corm is a dense reservoir of starch. Farmers do not eat Enset raw. They harvest it, scrape the inner flesh, and ferment it for weeks or months. The result is kocho, a thick, bread-like staple that has fed Ethiopian families for generations. Some process it further into bula, a finer starch used for porridge and special occasions. This is not fast food. This is slow security. Families plant Enset not for the next season, but for years ahead. A field of Enset is not a crop rotation. It is a living reserve, a food bank that grows in the soil rather than sitting in a warehouse. And unlike grain silos, it does not spoil. It does not require electricity or temperature control. It simply waits, alive and ready, until the moment it is needed. How one plant can feed a household. Most crops operate on annual cycles. You plant in spring and harvest in fall. If the harvest fails, you starve. Enset breaks that rule entirely. A single Enset plant takes anywhere from 4 to 10 years to reach full maturity. During that time, it stores energy continuously, building a reservoir of starch in its trunk and corm. When finally harvested, one mature plant can provide enough food for a single person for an entire month. Some estimates stretch that further. A small garden plot holding just 15 to 20 Enset plants can feed a family for years, not months. Years. This is not theoretical. In the Sidama, Guraj, and Hadia regions of Ethiopia, families have relied on this math for centuries. They stagger their plantings so that mature plants are always available. When drought strikes or crops fail elsewhere, they do not panic. They walk into their garden and harvest what has been waiting all along. The world measures food security in tons per hectare, in export yields, in commodity prices. But in Ethiopia's highlands, food security is measured in how many Enset plants stand behind your home. Quiet, patient, alive. 7. Nutrition without complexity. Fermented Enset is not a delicacy. It is sustenance. Kocho is dense, starchy, and filling. Bula is lighter, smoother, often reserved for children or the elderly. Neither will win culinary awards, but that is not the point. The point is survival, and survival does not require complexity. A single serving of kocho delivers slow-releasing carbohydrates that keep energy stable for hours. Combined with legumes, milk, or meat, it forms a nutritionally complete meal. Laboratory analysis reveals meaningful concentrations of fiber, potassium, calcium, and iron. What makes Enset extraordinary is not a single miraculous nutrient. It is the way it integrates with traditional food systems. When fermented properly, kocho becomes shelf-stable for years without refrigeration. No plastic packaging, no cold chain logistics, No industrial processing, just clay pots, underground pits, and knowledge passed from mother to daughter for generations. The world spends billions engineering shelf-stable food products. Enset has been doing it for millennia, and it requires nothing except the wisdom to prepare it correctly. That wisdom still exists. It lives in the hands of Ethiopian women who learned from their mothers, who learned from theirs. A lineage of knowledge as old as the plant itself. 6. Why Enset thrives where others die. Enset does not require perfect conditions. It requires almost nothing. It tolerates drought that would destroy maize within weeks. It survives irregular rainfall that devastates wheat. It grows on steep hillsides where tractors cannot reach, and where irrigation systems cannot function. Its roots do not merely extract from the soil, they protect it. Enset's dense root network prevents erosion on the mountain slopes of Ethiopia's highlands. Where other crops leave bare earth vulnerable to runoff, Enset holds the ground together. It builds soil structure rather than depleting it. As climate change accelerates, the world's grain belts face unprecedented stress. Heat waves, shifting rain patterns, seasons that no longer behave as they once did. The crops that feed billions were bred for stability, for predictable environments that no longer exist. Enset was bred for chaos. It evolved in a region defined by altitude extremes and unpredictable weather. It stores its energy underground, beyond the reach of drought. It does not demand consistency, it expects uncertainty. While scientists spend billions engineering drought-resistant varieties of rice and wheat, Enset already possesses what they are trying to create. The blueprint has existed for centuries. It just grows in a place the world refuses to notice. 5. So why did the world never adopt it? If Enset is so resilient, so calorie-dense, so reliable, then why does it remain confined to a single country? The answer is not biological, it is political. Enset does not fit modern agricultural systems. It grows slowly, maturing over years rather than months. It requires fermentation knowledge passed through generations, not factory processing. It cannot be harvested by combine or processed in industrial facilities designed for grain. Its value lives in the hands of the people who grow it. That is the problem. Agricultural development in the 20th century prioritized crops that could be standardized, exported, and controlled. Crops that fit shipping containers. Crops that could be processed in distant facilities and sold back to the regions that grew them. Enset does none of this. It feeds families directly. It stays local. It resists the logic of global supply chains. A crop that cannot be mechanized, cannot be scaled by corporations. A crop that requires cultural knowledge cannot be replicated by outsiders. A crop that provides years of food from a single planting does not generate repeat customers. Enset was not rejected because it failed. It was ignored because it succeeded in ways that benefited no one except the people who grew it. 4. A crop that does not make anyone rich. Consider what Enset does not require. It does not need synthetic fertilizers manufactured in chemical plants. It does not need pesticides engineered in laboratories. It does not need hybrid seeds purchased annually from corporations. It does not require irrigation infrastructure or fossil fuel-powered machinery. Plant it once, and it grows. Harvest it years later, and it feeds. No transactions in between. This is precisely why it never spread. Industrial agriculture is not designed to end hunger. It is designed to manage hunger profitably. Every input, every seed, every chemical application, every piece of equipment represents a revenue stream. Crops that require constant intervention generate constant purchases. Crops that eliminate intervention eliminate profit. Enset breaks the cycle entirely. A family with 20 Enset plants needs nothing from the outside world except time. They cannot be sold fertilizer they do not require. They cannot be sold seeds for a plant that regenerates itself. They cannot be made dependent on systems beyond their control. A food too free to commercialize is a food too dangerous to promote. And so it remains invisible in the regions where corporations look for markets and governments look for export revenue. 3. Suppression by systems that favor wheat and maize. Global agricultural research funding has never been neutral. For decades, money flowed toward crops that served international markets: wheat, maize, rice. Crops that could be grown at scale, processed centrally, and shipped worldwide. Crops that built supply chains benefiting wealthy nations. Enset received almost nothing. Research stations focused on yield improvements for export crops, while indigenous staples were dismissed as primitive, regional, and unscalable. Ethiopia itself was encouraged to expand wheat and maize production, often at the expense of traditional Enset cultivation. The logic seemed sound. Modern crops meant modern development, but the results told a different story. When drought struck, the modern crops failed. Enset survived. When supply chains broke, imported food disappeared. Enset remained. Hunger in vulnerable regions is rarely a shortage of food. It is a shortage of permission. Permission to grow what works locally rather than what profits globally. Permission to value indigenous knowledge over imported technology. Enset could have spread across Africa decades ago. It could have reached other continents with similar climates. Instead, it stayed confined to Ethiopia, while the world poured billions into crops that require constant intervention and that collapse under climate stress. 2. Why scientists are finally paying attention. Climate projections have changed the calculation. Researchers now model where crops can survive as temperatures rise and rainfall patterns shift. Enset appears on those maps in places it has never grown. Studies published in recent years show that Enset could thrive across large portions of East Africa, in Kenya, Uganda, Rwanda, and Tanzania. The same climate models suggest potential expansion into parts of South Asia and even South America. Researchers estimate that Enset cultivation could theoretically provide food security for over 100 million additional people beyond its current range. International agricultural centers have begun pilot programs. Scientists collaborate with Ethiopian farmers to understand the cultivation techniques that outsiders never documented. The plant that Western research ignored for a century is suddenly a subject of urgent study. Some call it Africa's climate-resilient supercrop. Others simply acknowledge what Ethiopian farmers always knew. Enset works. The question now is whether the world will allow it to spread, or whether the same forces that kept it invisible will find new reasons to suppress a crop that threatens no one except those who profit from hunger. Cool. The food future we almost forgot. Enset did not disappear because it was inferior. It did not fade because better options emerged. It remained hidden because it broke every rule of a food system designed for profit rather than people. A perennial crop that stores calories underground does not fit a world built on shipping containers and annual transactions. A plant that requires cultural knowledge rather than chemical inputs does not fit a system built on dependency. A food that ends hunger permanently does not fit an economy that requires hunger to persist. But the climate does not care about economies. Droughts do not respect supply chains. And when the modern crops fail, when the fragile monocultures collapse under heat, they were never designed to endure. Something ancient will still be growing. In the highlands of Ethiopia, Families will harvest what their ancestors planted. They will eat what the world ignored. And perhaps, finally, the rest of us will understand that the solution to hunger was never hidden. It was simply never allowed to spread. The tree against hunger still stands. It has been waiting for centuries. The only question is whether we are ready to listen.